Hello and welcome to this most wonderful time of the year. The Advent of Code is here. Advent of Code is an advent calendar of different programming challenges that you need to solve every day. Each day you will receive a new task which has two parts of it. So first one will be much simpler and will earn you 1 star. The second one will be iteration of the same problem but with some difficulties in addition, which will earn you the 2nd star. This is a great place where you can scratch your head and do something different besides that you do on your everyday job. And over the years this has become a great place where you can practice different programming languages. Challenge yourself, try to picking different language for solving these problems. For me this year will be Go, because I'm a bit rusty with it. Rusty. I'm already on day 5 and I'm a bit late with this video, but I will still recommend you first try to do that on your own and then only proceed with different videos and solutions to compare maybe your ideas. And that's the beautiful thing of Advent of Code. You don't need to have the most beautiful solution or the most right solution. As long as it solves the puzzle, it's good enough. Let's have some fun this holiday season and I challenge you to participate here. Solve all 12 puzzles this year. Let's start with the day 1. So day 1, the secret entrance. The elves have a good news and a bad news. The good news is that they discovered project management. Oh no. This has given them tools they need to prevent their usual Christmas emergency. For example, they know that the North Pole decorations need to be finished soon, so the other critical tasks can start on time. The bad news is that they realize they have different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. Very classical situation. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collect the stars by solving puzzles. So there are 2 parts. The second part unlocks only when you finish the first part. So let's start with the problem itself. You arrive at the secret entrance to the North Pole base ready to start decorating. Unfortunately, this password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains, due to the new security protocols, the password is locked in the safe below. How convenient. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. So it's like this safe dial from 0 to 99, so 100 positions. As you turn the dial, it makes small click noise as it reaches any number. The attachment document your puzzle input, so each of you will have your own input to solve. Contains a sequence of rotations, 1 per line, which tells you how to open the safe. A rotation starts with an L or R, which indicates whenever the rotation should be to the left or right, and then the distance. So it looks like this, a combination of left 68, right 48, so how many positions to dial. So here are some couple of examples. You could follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. So we need to count how many times after this dialing we have ended up at position 0. And here is a breakdown of one scenario which end up with password free. And as I have already solved this once, I already know my input, but still we will go through this problem. As I mentioned, I will use Go to solve these problems this year. You could use, of course, any language that you want, but I still will encourage you, try something different. This is a great opportunity to do something different. Try and learn new skills. Okay, so let's break down our problem. So we have a dial. We have here a 0, here a 99, and here is 1. And I think I missed actually a crucial part that the dial starts pointing at 50. So there is some set starting position. But that will come later. So we need to count how many times we have end up at the 0 again after any rotation. We should start by implementing the dialing mechanism, which would reset if you go over 99, or vice versa. If you go to the negative side, it should go back. So I will create a function part1. As input, it will receive list of strings and will return number integer, which will be how many times it end up at 0. By default, I will return 0. I can define that the position is 50. Of course, we would need also the dial size, which is 100. And then we should go over each line in this input range and process each line. Okay, I have a copilot enabled, but whatever. Let's see how it will help or not. Of course, the main problem here is the dialing part. And I usually want to break these problems into smaller, manageable steps which I can test and make sure that it works, because there will be a lot of debugging involved when finding what is the problem, why you're not getting the correct answer. And usually you want to mitigate the number of places you could go wrong. So I will extract this dial function, which will be only responsible for dialing this safe mechanism. And I will cover this with tests and make sure that it works. So if something goes wrong, I know that this is not the part. So okay, we will need some starting position, distance to move. Then we need to provide the direction. So these two are integers. This one will be string, and the dial size, because for the testing we could use something a bit different. And we'll return the new position back. So right now I will just return 0. Okay, this will cause me some pain points right now as it's not implemented. I will just comment it out and go to the tests. So I want to have a function that will test my dial part, and I will break down it into the two tests. Of course, it would be much better to have more and separated them, but I will have two cases, the left rotation and the right rotation. So test right dial. Let's import testing. And I want to have it as a multiple tests. I will define some structure for it. So the initial position, then the distance, the direction, then the dial size, and expected position at the end. So this will be my test structure. And for each of these test scenarios, I will run it as a dial, provide the position, the distance, the direction, the dial size. And if the positions do not match, I will output the error. I think it's simple enough. Now let's define some test cases. I will not go with these initial examples because it's an overkill. Let's start with something more simple. For example, I will start with position 0. I want to do 5 steps to the right with the dial size only of 10, because cognitively it's much easier for me to handle. So I will end up at the position 5. So that would be the expectation, right? So let's run the test, and now it should fail because it ended up at 0 and we want 5, as we did not implement any logic. But okay, let's start implementing this. Ideally, you want just to move the dial, so original position plus the distance, but the distance is depending on the direction, either the minus or plus. So let's define a sign, which by default will be 1, and if direction is left, let's assign sign as negative, then we can add here multiplication with this sign. And basically that is what we can do. So the new position will equal position plus sign times the distance. And we will return it back. Right? Quite simple. We just move it to some either left or right direction based by this distance, which is also controlled by the sign. So let's go with the test case, and our test passed. So we have covered the first scenario. So let's add more scenarios. So we have basic rotation to the right. Now maybe let's try not starting from 0. So let's start from 1, add 5, go to the right with again the dial size of 10. We should end up at position 6. Running the test. Everything is okay. So basic movement is all right. But now we know that we could end up in such scenario that we are here. We are adding the full rotation and ending up at 0 again, which would mean if I would add the distance, I will end up with 100. I need to transform this 100 back to 0. So let's define this test scenario. So for example, I'm at position 5. I want to move 5 positions to right in the 10 size dial, and I should end up at 0 again, not 10. So if I will run it now, we fail because we ended up at 10. So how we could solve this problem? Well, actually it's quite easy. We could use mathematical operations, right? So there is mod operator that we are probably familiar, and if not, let me break down what it does. Mod operator is best shown as an example. If we will have 100 and I would mod it by 30, basically what it is saying, I want to divide 100 by this 30. Now, of course, we see that there are whole numbers inside. Let's extract them. So there are 3 and we are left with 10 30s. And this is the result which will be returned by this operator. So it's the remainder. So what is on top of the fraction? So how it's useful for us? So if we have position 110 and we mod it by 100, we will end up with 1/10 over 100, which is one whole number and 10 100ths. Meaning that if my end result, I add it up and it ends up with 110, I can transform it with mod and just be left with this 10 instead. So basically we are removing the whole numbers from it. So it means here when I calculate the new position, I could go over the dial size. So I need to remove it from the equation. So if I will have 110, I will remove the 100. Okay, let's run the test. And everything is okay. Let's add more scenarios. So I want to start from 0 and I want to move 10 positions to right, which should again end up at 0. Indeed. Now I'm at 0, I want to move 11 positions. I should end up at the position 1. And that also works. And what about full 2 circles? So 21, still there are 2 times 10 and 1 more to go over. Let's run. Everything is okay. So we have implemented the right movement. Okay, so I will copy over this test scenario and now let's see about the left. So let's see and cover with similar scenarios. Let's start at its left, yes. Let's start, for example, with 5 and move 2 positions back. It should end up at 3. So running the test, such case we have covered. Now let's start at 5 and move 5 positions back. So we should end up at 0. Yes, indeed, it works. Now let's start at 5 but go 6 positions back, which means we need to now wrap over the circle and end up at 9. And here we have a failure because we received the -1. So we don't have implemented this scenario. And basically I think it's quite straightforward. You know how many positions you have went over. So if you know the whole size is 10, then you can just subtract this number from 10 and get the result. So if the new position ends up negative, let's add the dial size, or basically saying let's subtract it from the dial. It's the same thing, right? And everything is okay. So let's add 16. It would mean full circle and 1 more to get to this 9. Everything is okay here. So what here we had multiple circles, but I think it's clear enough that we have now also implemented the left movement. And it is working as expected. So now I know that the dialing logic is correct and I can proceed. I will now know that this will not be my pain point because I have broken down into the smaller step and implemented it. So let's go back to our input. So we know that the input will be this with this string. Let's then parse this line to get our separate values, right? So first of all, we need to get the direction, which will be just string of first element. Then we need to get the distance. We need to convert it to integer. Everything does it after the first element. It could throw an error, of course. We need to have this error variable and already violating good coding practices by skipping the error handling. But I know that the input is correct there, says every developer ever. And for simplicity, let's skip it right now. So now we calculate the new position by calling this dial function. And we need our password, which is our solution answer. And if the position has ended up at 0 at the end, we increment the password and return it. So that is the whole logic. So we have implemented the most crucial part, dial, and now we just pass the input. So let's go back to the problem and always start with this sample input, because that's the most explained example that you can test your code on. So in tests, I will define a function, test part1 on sample input, and the input will be these strings. I will paste, it's not quoted, and here I think their AI should help us, right? AI, hello? Yes, perfect. So expected password we can see here is free. So I can set it to free. Actual password will be running the input, and if they don't match, we throw an error here. Okay, let's see how it will work with the sample. And we have no violations, so we have solved the sample input. Now the time for our puzzle. So let's copy over this test and not the sample input, but the puzzle input. And here now I have copied over it into the file here, into the input file already. So you can find your input down somewhere, get your puzzle input. And in my case, I already solved, so I know what is the answer. I can use that in the assertion. So my expected value would be 1021. And now we need to have this input, but we want to read it from the file. So let's read file puzzle input, no, but just input, import OS. Then we want to have our input, which is strings split, which this string bytes. And as I'm on Windows, I need to add also the /r here. Okay, so we now have split into list of strings where each line is at its own position. We pass it here and compare. So let's run it, and boom, the first star is earned. Now when you will submit your solution, the second part will open up. For me, again, as I have solved it, it's already open, so let's continue reading. You're sure that it is the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to the newer security protocols, please use password method blah 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 until further notice. So there is some different password mechanism. You remember from the training seminar that it means that you're actually supposed to count the number of times any clicks causes the dial to point to 0. So not ending up at the 0, but anytime it crosses the 0 also. So again, here is the example, which with the sample input again would end up with 6. I could modify this existing code or whatever, but I like to follow the good coding practices and stick to the open-close principle. So this function is working at its own, and I should close it for the modification. As it is working and tested, it should be as it is, but it should be open for extension. I will implement my new function dial with clicks that will reuse the same thing, position, distance, direction, dial size, and will return two values, the new position of the dial and how many times it clicked on 0. Why I'm doing that? Because I do not need again to worry about this dialing mechanism. I have already implemented it and I have tested it. Okay, so we need to count our clicks, which will be 0 at the end, and will return the new position and clicks, but we need to also get the new position. Okay, so the clicks and new position are calculated, and we have our return back. So now we need to count those clicks. So we again have our circle, right, which is, and we should handle multiple scenarios. So one, for example, would be, so I'm at some position 2 again, and I have ended up at 0. So as previous dialing, right? And same goes for the negative one. I have been at 99, I go left position, and I end up at 0. So this is the same scenario that we had basically in previous one. So we could naively try to put here that if the new position is equal to 0, then we say clicks ++ and increment that. And again, what is the best way how to verify it with this functionality is go with the tests. I will take this test right dial and we go dial with clicks. We will add here expected clicks. So these are not valid anymore. And here we will do on the clicks. So dial with clicks, actual clicks, and add one more if scenario. Of course, I should better to add some assertion library, but let's keep things simple here. Okay, now let's add those scenarios. So for example, I start at 0. I move 5 positions to the right with the, again, dial size of 10. I should end up at position 5 with 0 clicks. Yes, it works as expected. Now I'm on position 1. I move 5. So again, just to go away from the 0, no clicks should occur. Nice. So now I'm the position 5. I move 5 positions to the right. I should end up at 0 with 1 click. Yes, indeed, that is the case. Now I want to have 6. So I'm over the 0 by 1, but still 1 click. And now we have our first failure where we are saying that we are not counting clicks. It should be 1, but we have 0. Why? Because we are only counting those that were at the 0. So now here we need to figure it out how to understand that we have crossed the 0 while moving to the right side. Well, one way would be if we are here, for example, at 90 and we have moved right till 10, we see that we could compare those numbers, right? Which is smaller, which is larger. But that is not always the case that it could be, because we could also go over this 90. But what if we would know the rotation? How much positions did we go? So here right now, we have went to 20 positions and we end up at 10. And if we will subtract this 20 from 10, we will get back to negative value, meaning that we have crossed the 0. That could work. So how we could find the rotation? Well, it's quite actually easy, because you need to divide distance by this mod operator using the dial size. So what it means, so if distance was 30, I would move, divided by 100, I would move 30. Mod by 100, I would move 30. If it would be 130, I would remove the whole number and still get the 30 value. So the rotation will be constant, irrelevant of these full circles. Okay, so now if the direction was right, so we incremented. Now if I will remove from the new position the rotation and it's negative, so we have crossed it, then we can say there is another click to do. So let's run it and everything is okay. So we now have covered this scenario as well. Let's see one more case. What will be if we add one more full circle? So it means we go one full circle and then we cross one more time and end up at 1. So we need to end up with 2 here. So let's run. And we have failure, because we know that this actually ended up with 1, but we wanted 2. So where is the problem here? Well, actually, we could go multiple full circles, right? It could be 500, 600, 700. We need to find out how many full rotations there were. And the best way how to find it out is to divide by the dial size and just leave the integer part. Basically doing the integer division. So full rotations would be distance divided by the dial size. Now, we can always add the full rotations to clicks because we are removing those from the movement, right? So when we are doing the rotation, we are ignoring the full rotations anyway. So now we add the full rotations, and if we go over by 1 at the end. So let's run the test. And we have successfully solved it in this manner. Okay, I could just to double check add 2 full rotations and end up at 3. Yes, indeed. So it looks like the right movement has been solved. Let's go for the left now. Left with clicks. And now let's again start with some simpler scenarios. So we start at 5. We try to move 3 positions left. We should end up at 2 with no clicks. Looks okay. Now we are at 5. So move 5. So we end up at 0 and it should be 1 click and it's okay. Now let's go over 1. So we go over 1 element, still 1 click, but we should end up at 9. And here is our first problem, similarly with the logic with the right. Here we need to have something similar, that if the direction was left, and we know the new position plus rotation is larger than the dial size, so we have crossed the dial size. Then we increment it with clicks. So if we were at 1, we go 6 positions back, we end up at 5, and we add this again, rotation back 6, it should be 11, which crosses our dial size threshold. Okay, let's run the test scenario here, and it is okay. Let's again increment by 10, it would mean that there should be 2 full circles. Looks like that we are done here. So let's test now with the sample input again and run the part 2 on it. Part 2, which is actually not implemented yet. I already jumped over it. So this was the part 1. So we need to repeat most of the steps here. Part 2. The processing is the same. Now we need to go with dials with clicks, store here clicks, and our password now will be incremented by this clicks amount. But this position is colliding with that one, so let's call it new position and wrap them over. So now we have implemented the part 2. So basically the same type, instead of counting the zeros, we now count these clicks. Okay, here it is expected password was now for the sample input 6. And let's see if we have solved it. And for the sample input, we could get the correct result. And now the moment of truth. Let's take the puzzle input. So part 2 with the puzzle input. And as I said, I have already completed it. This is my output for my problem. I will put it here and let's see if it works. Success! We have solved day 1 and earned our first 2 stars. I hope it was something different and something interesting for you. You can see that these problems could be all over the place. It's just something to scratch your head and be a bit and go away a bit from your day-to-day work. And of course I would still recommend you to solve these problems on your own first. It's not the race, it's not the challenge who does the best and how the fastest solution. It's just practicing the most important skills that you have, the problem solving. Let me know down in the comments if you know any other clever ways how you can solve this. I hope you enjoyed such content. Leave a like, subscribe so you don't miss the next one. But until then, keep coding and I see you next time.